Hello and welcome to a bite-sized dev video. In this one, we're going to be doing a little bit of problem solving. I'm going to go over a leak code problem, num-good pairs. And what we're going to do is we're just going to do a first pass solution. So it's going to be a brute force approach. And then as we go forward, I'll probably make some more videos. In fact, the video after this hopefully will be doing a slightly more in-depth and second pass solution to this. This video is not necessarily about num-good pairs itself. It's more about the process that I'm going to take to solve a problem. Just utilizing a problem so that I can actually solve it. So let's jump in. We've got num-good pairs. Let's have a little look at the first steps as to what I would want to do when trying to solve a problem. Well, the first thing is sort of look at what it's asking. So it's saying, given an array of integers, nums, a pair, and it's got a tuple here saying I and j, is called a good one. So it's a good pair if nums at I is equal to nums at j. So we've got sort of a stipulation here. And I is less than j. So now we've kind of got this whole fairly clear and concise information. So, I mean, it's an easy problem. So we expect it to have fairly clear information. And it's expected to return the number of good pairs. Okay. First thing that comes to mind is literally a brute force iteration over a list. Perhaps because it's got two indices as well, we could presume that they're expecting us to do a nested loop of some sort or iteration. And the fact that it's a nested one, we could just keep the constraints of I and j based upon sort of making sure that j is always I plus 1 with every inner iteration, for instance. But before we go over that, let's take a look at some of the data, because we need to kind of see the flow of data. We've got a feel for what it's asking of us. So let's have a look. We've got the flow. We've got some data here. We've got a 1, 2, 3, 1, 1, 3. And that's the input. The expected output is a 4. To say that there are 4 good pairs. So it looks like we need to keep count of how many good pairs there are when going through this data. It's got an explanation. There are 4 good pairs, and it shows us the indices, I and j. So I is 0, j is 3. So I is 0, which equals a 1. J is 3, 0, 1, 2, 3. And there's another 1. And same again, I is 0, j is 4. I is 3, 0, 1, 2, 3, and j is 4, and then 2 and 5. So 0, 1, 2, so I is 2, and j is 5, which is over here, is 3. And it's 0 index, so there's 0 and there's 5, as in talking about indices, not the actual literal numbers inside nums. So that in itself could be a flow. We can draw that out. I'll actually whiteboard it in a moment. I did draw out a few beforehand just as a tester, but I'm going to draw it out fresh for the video. So the other thing is we've got some constraints. So always be mindful of the constraints. Like some of the constraints may say that you need to get a certain runtime, so the speed of operation. Certain ones may say that you've got to do it in a certain space complexity or a time complexity. This one's just stipulating that it's going to be a length. Nums is going to be a length between 1 and 100. So at most, it's going to have 100 items in there. And each of the integers or the numbers are going to be between 1 and 100 as well. If we look at the type hinting and stuff here in our solution code, it's saying it's a class solution. It's going to take in nums, which is expected to be a list of integers, and it's expecting the output to be an integer. Okay. So let's actually draw the process. I've wrote down some process. So I've made a copy of this for the whatchamacall, but for now I'm just going to make a new grab, and I'm going to grab this and the example there for now. And what I'll do is I'll put this into a whiteboard and we'll start looking at the flow of the data, because that's the next sort of steps. First is the understanding and thought process of what's going to be there and what the constraints are. Then it's a case of literally drawing out some diagrams and figuring out the flow of the actual thing. So let's copy this and I'll paste this into the whiteboard. I'm going to move it over here and make it a bit bigger so we can kind of draw on it a bit easier. Maybe make it about that big. So now I'm going to get the pen out and start sort of flowing through this. So I'm going to say I, for now, is for the first iteration of I, it's going to be red. So what I want to do is I want to go over this data. So I need to think of some variables. What we've got I and j. So I want to keep track of I want to keep track of j. Yeah. We're going to be doing a test. So these are the indices I want to keep track of. We're going to be doing a test look. Nums at I, nums at j. So we know that there's going to be some sort of if condition within this. And this constraint can be kept by doing a nested loop. So what we'll say is we'll do I in one color and j in another color. I'll do j in blue rather than in red. Sorry, that should have been blue. Actually, I'll erase that and make it blue. So we'll keep track of I and j. Okay. So they need to be set during the process. But let's say I is going to initialize at 0. So I is going to start here. So I is 0 at this point. Okay. So j, if I make j 0, that's not going to be a pair. So there's no point in starting it from the same place that I is. And we can keep this constraint where j is greater than I by literally initializing j to I plus 1. It should be here. So j is I plus 1, which is a 1. Okay. And then what we're going to do is we're going to check, is our nums at I equal to nums at j? So is it? So the other thing is, I said we need to kind of keep a kind of count. So this good pairs here, this could be our counter. So I'll just say C for counter and start it at 0. And then on every check, as we check, if it is true, then we increment our counter. Yeah. So we keep doing that check with every iteration. So this is our first iteration. We're checking the red circle versus the blue circle. So is the 1 equal to 2? No, it's not. So that's fine. We don't change C. But we need to move J across. So now J is equal to this. J goes here. So now it's 1 and 3 we're checking. So is 1 equal to 3? No, it's not. So we move on. So J was the 1, then it was 2. I, if you'll notice, is still 0 throughout this. So now it's moving on. Now it's 3. So now if we look, is 1 equal to 1? Well, yes, it is. So now that means that we're going to increment C, because that's true. Okay. Once we've done that, we'll move on to the next one. So now J is actually equal to 4. But 1 equal to 1, let's do our test. Is 1 equal to 1? Yes, it is. Therefore, we're going to increment C. And let's increment J because we're moving on to the next one. So J now moves over here, which is actually means it equals 5. Notice how I is still equal to 0. Now we're going to check, is 1 equal to 3? No, it's not. So we're not going to do anything to C. So 0, 1, that was a 2, sorry. Get off by one bug there. Right, so now we've kind of gone through one iteration of J. Let's change the color of J at this point in a moment. Actually, no. Yeah, we'll stick with red for I. So now I has moved over to here because we need to increment I on the next iteration. Once J reaches the end, we need to increment I. So I is now 1. J is another color. Let's change it to this color. So we can sort of cross that out. J is going to be equal to I plus 1. So if I is 1, j is going to be equal to 2. Yeah. So there's I. Now j is sitting here now. J is this one. So we're going to go through the same process again. So is 2 equal to 3? And that's, no, it's not. So we're not going to do anything to C. Now we're incrementing j. So now j equals 3. So let's move j over to there. So now, is 2 equal to 1? No, it's not. So we're not going to do anything to C. And we'll increment j again, which will make j equal to 4, which moves it over here. And again, is 2 equal to 1? No, it's not. So let's continue on. J's reached the end, but let's check it. So is 2 equal to 3? No, it's not. So we're doing nothing to C. And that's that iteration done. Once we reach that iteration done, we need to increment I, sorry. So now I is equal to 2. So let's denote that in our diagram. So I is equal to 2, which represents a 3. And remember that j can change color now. So let's have j over here. And now remember that j needs to equal I plus 1. So that j is now equal to 3. Okay, so 0, 1, 2, 3. So j is actually here for its starting point. Yeah. So now we check. Is 3 equal to 3? Is 3 equal to 1? No, it's not. Therefore, we don't increment our C at all. So now we increment our j though. So our j is equal to 4, which moves j over here. And we do the same. We do is 3 equal to 1? No, it's not. So we don't do anything to C. But j needs to increment. So j turns into a 5, which moves it over here. Which means, is 3 equal to 3? Yes, it is. So now we have, instead of it equaling 2 now, we're incrementing it and it equals 3. So we've incremented C because that was true. Okay. But now we've finished our iteration of j. So that means we need to add 1 to I. We need to increment I. So let's increment I. I is now 3. But that means that we need to go to j, like so, and that needs to be I plus 1. So j is going to start at 4. So let's do that. So I is currently here, and j is currently here. Okay. So now we're going to check, is 1 equal to 1? And that's true. So that means we increment C. So now C becomes 4. And we increment j, which becomes 5. So now j is over here. And we still do our test. We go, is 1 equal to 3? No, it's not. So we don't increment C anymore. So C is still 4. And we can't go any more with j. So that's done. Okay, so we've done that one, and we've done this one. But now we can increment I, just for completeness. So we increment I, and I moves over here. So I is now 4. Okay, which also means now that we need to increment j. So I'll do the last j in black, why not? So now j is equal to I plus 1, so j is equal to 5. So it hasn't got very far to go. So now j is equal to 5 here. Okay, so now, is 1 equal to 3? No, it's not. So we don't increment we don't increment our C. We try to increment our j, but we can't because we've finished with it. So that's done. And now we increment our I. Okay, so now we're back to the outer loop again, which hits a 5. But now I is here. We don't get to the j equals I plus 1 because I has finished. It's hit 5. So it's done. So our entire process and loop is finished. And now we're left with this good pairs C equaling 4. So what we can then do is we can return the number of good pairs. So we return a 4 to the caller. Okay, so now we get our result of 4. So based on that process, this means that we should be able to do a brute force approach. We've just manually done one step by step. We've looked at the flow of the data as it went forward. So now let's write that out in terms that we can think of. So let's go over here and I'll type up, let's kind of zoom in a little bit so we can kind of see it a bit easier. So here I'm going to type up in my own words what I want to do. So I want to keep track of good pairs. So that'll be a counter of some sort. Okay. I want to iterate over all of the nums, not muns, nums. Okay. And let's see, how do I want to use a nested, using a nested for loop. So in other words, 2 loops. Using, let's say, using I and J as the indices. Okay, so that's kind of what I want to do. Then within that, I want to then check nums at I, check if nums at I are equal to nums at J. Okay. Let's say also making sure that J starts each of its iterations I plus 1. Yeah. So we need to make that stipulation to cover that requirement. So then check if the nums are equal to at I are equal to the nums at J. If they are, if this is true, then increment the good pairs. Okay. Then once all iterations, iterations are finished, return the good pairs to the caller. Okay, we now have distilled an algorithm. So first we started with the problem set. We looked at that. We kind of looked at an example and then ran through the flow of that example. Then distilled an algorithm from that. And now we can actually just code it up. The coding part is literally the most trivial portion of any problem solving. This is one of the main takeaways I want you to have. Okay. So first I want to keep track of the good pairs. So good pairs equals 0. Okay, so that's cool. So we've got our counter. Iterate over the numbers. So first I want to say for I in range, and the range what I want is the length of my numbers. And remembering that J wants to be equal to I plus 1. So I still want to do a range, but I want to start from I plus 1. And then I can end saying len of nums. Okay, so now we've stipulated enough to make sure that this is true at all times. Okay. Now all we need to do is say, well, if nums at I are equal to nums at J, if that's true, then I just want to take my good pairs and increment them. And once I've finished all of those iterations, I just want to return my good pairs. That's, look how simplest. There's not a lot there really, is there? Come on. I mean, yes, it's a first pass solution. Yes, it's a quadratic runtime. So this is going to be a first pass brute force solution with a runtime of O of n. Where's my squared? O of n squared. So a quadratic runtime. Yeah. So that's literally what that is. That's just a first pass brute force solution, and it's going to be using a quadratic runtime. So it's not the best solution out there. It's like probably the worst one you could think of, but it gets the job done. And that's the first thing that you want to do. It's like the first step that you want to show any interviewer is, yes, I can step through the process of solving a problem. Then you can move forward and maybe do a second pass solution. I'm not going to do that in this video, but we'll do a to-do second pass solution. So that'll be more to come. Okay. And that's basically it. We can run some testing as well. Once you've done that, you'll want to kind of run some tests and see how it goes. So, I mean, we could run this in here if I was a member, but I'm not actually signed up to LeetCode. I'll have to do that at some point so we can kind of go over a load of different tests. Or the other option is literally, let's have a look. I've got what's it here? Make a directory for it, num pairs, we'll call it, or something, cd into num pairs, go into VS Code, and literally, I'm going to just literally paste my solution that I've just wrote. So let's grab the whole of this, and I'll kind of refactor it for VS Code. So yeah, let's have a look. So let's bring this up. Close that off. New file, num good pairs.py. Once it actually makes that. Typical in live code. Let's have it wait for ages to do something. Wow. Okay, perhaps I shouldn't have done this. I should have just done it in a REPL or something. But okay, so let's do this. So we've now got this. I don't want it in a class specifically just for this, so I can just do that and then shift and tab to bring that in. Okay, so here's my num-good pairs. Now I want to do like some tests. Now I only want to do one test because it's going to be a simple basic starter. So let's move this over and grab the inputs. Okay. And then what I'm going to do is I'll say print num good, what did I call it? Just num pairs or not? Num pairs, good pairs even. Okay. Good pairs. Huh? What was it called? Oh, it's called it num identical pairs. Sorry. I'm just kind of trying to write how I would have wrote it. Okay. So num identical pairs, and I want to pass that in as, no, not that. I want to pass in the, this, copy that, and grab my thing. A little bit of jumping about with this because I didn't particularly plan on testing, to be honest, but this little bit of bonus. I'm going to select my Python interpreter for now. Right, so now it's going to test this, and we're going to expect it to output a 4. Let's see if I've broke anything. This is always good fun. Live code for the win. So this is a test to see, based on what we've just gone through, this should return a 4. Okay, let's go and run it. So Python 3 good pairs, and I've broke it. 4A. Oh, typo. This is another reason why you always test your code. Blah, blah, list is not defined. What's that saying? Oh, that's just this moaning about this lot here. And self. Move that out of the way. Let's clean this up because that's just my linter moaning. Just having to refact. There we go. So it's a 4. After a bit of refactoring and fixing a typo, so I need to fix that typo over here as well. Hopefully bonus points for anyone who actually noticed that and was screaming at the screen saying, put in there. But having said that, that's pretty much the process. Obviously, you've even gone through and saw the other process of the issues, what I'll get if I do a typo. And luckily, because we actually tested it, we were able to find that typo and fix the problem. So now we got our first pass solution. We still need to do a second pass solution, but I'll do that in another video because this bite size dev video has kind of gone quite long. So hopefully that was useful as a process. See, the actual problem itself and the solution itself are almost irrelevant. It's more a case of what the process was to get there. So what I'm going to do is I'm going to actually put this into a repo so we can get access to this. I'll upload this video to YouTube along with the actual diagram, perhaps, or a link. I know what I'll do. I'll put the diagram also in a repo as well. Again, this is going to be slightly rough edit because basically this is going to be my first video for this channel as such. So we'll move forward and we'll take feedback, see whether you prefer longer videos, whether you prefer shorter videos and things like that. But moving forward, I'll probably be making quite a few of these. And again, my next one, hopefully planned, is going to be the second pass solution for this. So I'll be looking at example 2 and then using that to distill a second pass solution. And you'll see the thought process from start to finish for that as well. Again, it's not necessarily about this problem itself. It's about the thought process going into the problem solving. Okay. That being said, thanks a lot for watching, everyone. I've had a lot of fun making this and hopefully you've enjoyed it. I'll see you in the next video.